remote areas, connectivity would have a huge effect on people's lifestyles, business opportunities, and society as a whole. This will help bridge the digital divide while also improving healthcare, education, transportation, agriculture, electricity, manufacturing, and jobs. Distance learning and interactive teaching, for example, can increase education quality when supported by broadband connection. Services such as e-agriculture and weather forecasting can aid in increasing agricultural productivity and reducing losses. Services in remote areas that we cannot imagine now could be available in the future. An example that is currently conceivable is the increased use of virtual and augmented reality in healthcare, which will require high-speed connectivity. People live and work in remote areas. Regular and cellular technology, as well as Wi-Fi, may be used to reach remote areas. However, they may be far from major roads, without access to power grids, or without communication fibers, so they might not have connection at all, not always at least. To communicate in their remote areas, people will need robust, easy to use, and safe devices. Maintenance of remote areas equipment should be simple. People may be poor in villages or remote areas, so the expected average revenue per user would be small. To run these connections, and new and more efficient operation models may be needed from the design. User devices shouldn't be expensive. Edge computing may offer tools to use expensive and perhaps limited backhaul efficiently. Example for that, allowing traffic prioritization based on local needs only. Backhauls are needed to connect remote areas to global internet. Current solutions include sea and land cables or fibers, microwaves and satellites, and other non-terrestrial network components. But they are not feasible. They are not feasible everywhere and for all. Global and economically feasible solutions are needed. Coverage is also needed in difficult environments such as mountain valleys, where some people tend to move and work around in remote areas. Direct user device access via satellite systems or large cells is a possible solution, but current usage costs and low data speeds, as well as lack of coverage, are the key limiting factors. In the remote areas, ships and airplanes need connectivity for operations, maintenance, and reporting, as well as for the staff and passengers. Special needs such as protection and rescue missions should not be overlooked, as they are naturally of concern and will benefit from better connection in remote areas. Communication systems are not standalone solutions, but belong to a wide technology spectrum in remote areas. Understanding local culture is important, as is ensuring that the group is active and trusts those providing communication services. This is true in developing countries especially. Security and authentication solutions should take into account the need of people living in remote areas, who are mostly local tribe people, to absorb new technologies. They have to be immersed in the technology and the installation of their new 6G at least. Remote areas challenges. They have to be affordable, low-cost solution. The technology must be cheap. That's the first one, because number of users in a village is usually less than an urban, so it should be sufficient. Not just the coverage, but also sufficient 24 hours a day for a week. Solutions must be environmentally friendly. Cultural aspects may affect how technology is accepted and used.